Hi everyone, welcome to this channel. So today we will be diving into the world of supervised learning with an exciting project using linear regression. So what is this project all about? So here today I will teach you how to analyze an advertising dataset and to predict sales and see how different marketing strategies impact the revenue. So, if you are interested in machine learning or data science, so stick around till the end and make sure to like, share, and subscribe if you find this helpful. So, we have an advertising data set that contain information on how different ad channels like TV, radio, and newspapers affect product sales. And our goal is to build a supervised learning model that can predict sales based on the advertising spends using ChatGPT to be noted. In simple terms, I will teach you how to create the model and to find the patterns between the advertising budget and sales so that it can predict the future sales based on new advertising data. So first thing first, as we are using ChatGPT here, so I have asked ChatGPT on how to apply Python and machine learning algorithm to apply supervised learnings to analyze and predict trends on advertising dataset. The dataset contain information on various advertising channels and their impact on sales. So here ChatGPT has guided me on the dataset first. So as you can see that the dataset have 200 entries and 4 columns. The dataset basically shows the advertising budget spent on each of the channels, TV, radio and newspapers, and the dependent variable of the sales that they made on a particular number of years. So it gave me few step by step codes on how to import it and how to run it. So I will teach you basically what this code is all about and how can you interpret this and make your machine learning model creation journey easy. So as I have already created the project, so I will explain you step by step. So first thing first, the regression equation. So as you know, this is the regression equation. Y is equals to b naught plus b1x1 plus b2x2 and so on. So first, I have installed the scikit-learn. So scikit-learn is a machine learning library. So if you don't have this scikit-learn installed in your environment, so you can install it. It is pip install scikit-learn. It will install the machine learning algorithm. Then we have to import some necessary libraries like NumPy, Pandas, Matplotlib. So NumPy helps in handling the numerical computations, whereas Pandas helps in manipulating and analyzing the dataset. And Matplotlib is used for data visualization. And here we have within the project we have also imported Seaborn. Seaborn is also used for visualization but for advanced visualizations, and we have also applied these warning filters to suppress any unnecessary warnings to keep output clean basically. So all these libraries are essential for data analysis and visualization. So step 2 is to load your dataset. So to load your dataset, you can use this pd.read underscore csv, and you can just copy the path of your dataset and then put an R in front of it and then run it as in head and tail. So dot head will give you the first 5 column of the dataset, and dot tail will give you the last 5 column of the dataset. So basically, we have used here SNS pair plot. So pair plot is used for finding the relationship within the columns or within the sales and TV or sales newspaper or sales radio. So here it has given the results in scatter plot. So from this we can interpret that the relationship between TV and sales shows a very strong correlation. The sales increases with the spending, and here for the newspaper it is very randomly distributed, whereas for the radio it shows a very weak correlation. It shows some increase in sales with some higher ad spending on radios. Whereas now coming to the this heat map, so we have used sns.heatmap, and after that plt.shows give us the results. So we have this and not is true, and not in the sense it will show you the values here that is written. Then a cmap. Cmap is used for changing the color. So I have used crest here, so this is the color for the crest. And yeah, so from this chart, we can interpret that the correlation between the TV and sales shows zero point 0.9, which shows a very strong correlation as TV has highly impact sales, whereas in the radio it shows a moderate correlation, and in newspaper it shows a weak correlation. From these, we can analyze that the TV advertising is the most effective in driving sales. Next step is to splitting the data into training and testing. And for that, we have used this sklearn model code. So, sklearn model code is used to split the data set into 70% training data and 30% testing data. So, the training data is used to train the model, and testing data is used to evaluate the model. And here we have used this random state is equals to 100 that ensures the reproducibility, so that you will get the same split every time. Into the stats model. So we have imported stats model here. So it is basically training the regression model. So here we have used x trains, I mean sm dot add constant. So it will add in context, intercept to the model. And for the sm.ols is basically the ordinary least square. So it will fix the model using OLS. So the sm.add constant data will add an intercept to the regression equation, and the sm.ols code will perform a linear regression using ordinary least square. And OLS is a standard technique for the regression model. That's why we are using it. Now coming to the next step. So next step is understanding the regression coefficient, as in to display the intercept and coefficient of the regression model. So as we know that the regression equation, as we have discussed above, so in this case the regression equation will be sales is equals to b naught plus b naught into TV plus b naught into radio plus b naught into newspapers, and the coefficient tells us how each feature affects sales. So that's why we have used this lr.params code, and then further we have simply printed the summary of that code, and that summary gives the detailed of the regression model. So the r square measures tells us how well the model explains the data set, and if it is closer to 1, we are good to go. And here you can see that it is 0.816, which is much closer to 1, so we are good to go. Now coming to the next step. The next step is all about making the predictions. So as we have trained and tested the data set, so here we will add an intercept to x test to match the training data set. So here we have added another constant to the intercept, or we can say that we have added another intercept, and for this one we are predicting the sales for the test data. Then the next step is to evaluate our model's accuracy. And for that, we have used the sklearn metrics. Here we have used the RMSE, which is root mean square error, which helps the square root of MSE, which is mean squared error, on giving errors in actual units. And then further we have used R square. We need the R square value in order to measure how well the model explains the data. So if the R square value is closer to 1 as above, so we are good to go and we are in a better state. And here the R square value states that 0 0.7. So it is much closer to 1. We will move ahead to the final step, which is the data visualization part. So here basically we have asked for the scatter plot to predict the actual versus predicted sales. So here we can see that the comparison shows a very strong correlation between the actual and predicted sales. And that is how, my friend, we build a supervised learning model using linear regression to predict sales. We analyze an advertising dataset, trained a model, and evaluated its performance. So, if you found this video helpful, don't forget to like, share, and subscribe. And let me know in the comments if you have any questions you want or more tutorials like this. Thank you.